Hi everyone,
I'm Gabby.
and I'm Jay, and this is our journey to a very long equation.
As we mentioned in our How to Calculate Your Savings Goal video, my brother Antonio helped us out with this equation, and we wanted to share a more thorough explanation he put together for us.
By the way, Antonio is a little camera shy, so here is his stand-in, Mikey.
In this video, I'm going to show you how this equation comes about that was used for Gabby and Jay's video on how much you need to save over a course of a couple of years in order to accumulate a certain amount of money, assuming a certain annual rate of return of your investments. So this is the equation here, and this is the simplified form of that equation, which you can actually plug in your numbers to calculate what that amount of savings per year would be. Okay, so I'm going to show you how we got there. So let's just start with a simple example. First, S is the amount of money that you're going to set aside each year, basically your savings in cash. This is what we don't know. This is what we're going to try to figure out. N is the number of years in which you're going to save. And X is the total amount accumulated over those N years, assuming that you save S. So the equation would be the amount of money that you set aside each year times the number of years gives you the total amount that you accumulate. So it's pretty simple. So for example, if you set aside $50,000 each year, so you save $50,000 for 20 years, then you're going to get $1 million at the end of those 20 years. But if, for example, you're 20 years, now you want to do it in 10 years, but you want to save the same amount, the same $1 million, well, now instead of $50,000 that you're going to put aside, you're going to put aside $100,000. So that's pretty straightforward. But now we're going to bring in a new variable, R, the annual rate of return of your investments. Basically, every time you set aside money, that money is going to grow every year because it's invested, and it's going to grow at this rate. So this is kind of like your return of your investments, like say 10%, 7%, whatever you want to assume there. But once you incorporate that R, things get a little more complicated. So I'm going to show you how we get to that final equation. So let's go through a little example. Let's say that at the very beginning, let's think of it as January of the very first year, you put in S, a certain amount of money. Let's call it $10,000 for this example so that we have a number to work with. And we're going to assume that R is 10%. Basically, our investments are making a 10% annual rate of return. So each year they grow by 10%. By the time we get to January of the following year, that first S has grown to S times 1 plus R, which means that $10,000 is now $11,000. That's because of the growth in a year. And then because we're in January of the following year, we are going to put in another S. Basically, you set aside the money for that year. So now we go to the next year, and now that first S that grew, so the first $10,000 that grew to $11,000, now it's going to grow to $12,100 because it just keeps growing and growing because of that rate of return. So the equation for that would be S times 1 plus R, but you multiply it times 1 plus R twice. That's why you have this exponent of 2. And then this other S, well, that grows by the same as this one here. So grows by 1 year, so it goes from 10,000 to 11,000, so you multiply it by 1 plus R. And then because we're January of another year, we add another S, okay? And we keep going. So for year 3, this S has now grown by 3 years, so that's why we put that exponent there. This S here has grown only by 2 years, that's why the exponent is 2. This one has only grown by 1 year, so that's why this has the equivalent of an exponent 1, and so on and so forth, and we put another S. So once we get to year N, basically whatever that is, 10, 20, whatever you want to save for, this first S has grown by 1 plus R to the N because it's saved up for N years. The second one is has saved up N minus 1 years, right? Because that first year, you didn't have that other S, so it's N minus 1. And then the next term would be the same thing with N minus 2, and so on and so on and so forth. So that's the equation there. And if you add up all of those terms, you get X, the total amount of money that you accumulate over those N years. So the equation for this, another way to write it, is the sum of S times 1 plus R to the little n. Now this little n is just a counter. It's just kind of saying what year we're on at each time. So year 1, year 2, year 3, and so forth. And if you do this whole sum, you end up with X, the total amount of money that you've accumulated over that N amount of years. So that's the equation there. Now we're going to make a couple simplifications here. First of all, S is assumed to be constant. Basically, you're saving up the same amount of money each year. You're setting aside the same amount of money each year. So because S is a constant, we can move it outside of this sum. So let's do that. So now S is here outside of the sum. And now, because S is the thing that we're looking for, is how much money do I need to set aside in order to reach my goal of X within this N years. So we're going to take this whole sum here and we're going to move it to the denominator here. So there. And that gives you this final equation that you saw in the first slide. So that's kind of where this thing comes from. Now, the problem here is that this equation has a sum in the denominator. And usually when you have a sum, it's really hard to just plug in numbers and see what you get. So we're going to do a little bit of a simplification in order to make it more useful. But this equation is true. All right, so let's do that. So this is the same equation as we had before. And what we're going to do is we're going to use this other equation, which is for any sum of 1 plus r to the n, from n equals 1 to n, basically we can write it as this. This is, if you want to get technical, this is the equation for the partial sum of this guy. So the cool thing about the right-hand side of this equation is that if you use this, then you can actually plug in your numbers and back out what this S would be. So it makes it a lot easier to work with. So let's do that. So if we basically substitute instead of this, which is in here, we're going to substitute this thing in there, you end up with this final equation. So this is the final equation for this, and you can plug in your numbers. You can plug in what your goal amount of money that you want to accumulate is, or X. You can plug in how many years you want to, in how many years you want to achieve that goal, basically N. And then you plug in this R, which is what is your assumed rate of return for your investments. And that'll tell you what is S, how much money you need to save each year or set aside each year in order to achieve that goal, in order to make that equation work. So let's go through some examples. So that's the equation up there. These are kind of the same examples now that we did at the very beginning, but now assuming a certain R. And in this case, I'm going to assume 10% just because it's easier to work with. So let's say you want to save this in 20 years. You want to save $1 million and you're going to assume 10% rate of return of your investments. Well, when you plug it into this equation, you get S equals $15,000, okay, or $15,800, almost $16,000. So if you set aside $16,000 each year and you assume that you get a rate of return of your investment of 10%, in 20 years, you're going to be able to reach $1 million. So now, just like the other example, what happens if you want to drop your N now to 10 years? So if you want to do this in 10 years, you want to save up the same amount of money, X, and assuming the same rate of return, R, well, now you need to set aside $57,000. So that's kind of how this equation is going to work. So you can use this to kind of calculate how much you need to save each year, in order to reach your goal. And let's contrast this with the original examples, which assumed no growth. Remember, this was the equation S times N equals X, okay? So that one was the one with no growth. So for example, if you assume no growth and you want to save $1 million in 20 years, you're going to have to put aside 50,000. If you do invest your money and you get a rate of return, say of 10%, then you're only going to have to set aside $15,000 because your money is going to grow in and of itself. Same thing with this side here. If you want to save in 10 years for $1 million, you only have to put in $57,000 if you get a 10% rate of return. If you have no rate of return, no growth, you have to set aside $100,000. And another way to see this is kind of with these graphs. So these are the same examples. X equals $1 million, and you want to do it in 20 years. But now what I've done here is that this x-axis is R. So for different rates of return, so our example was here in 10% rate of return. So for 10% rate of return, in order to reach $1 million, you would need to save, remember, about like, what was it, $16,000. But if you have a smaller rate of return, let's say 7%, well, you're going to have to set aside a little bit more. This is that S of how much you need to save. And in the example, the original example, if you have 0% rate of return, well, now you're going to have to save up $50,000 each year in order to reach $1 million. And now in the example for 10 years, it's the same thing. You come over here, this is your R, and this is your S. So for the very, very first example where you had 0 rate of return or no growth, you had to set aside $100,000, right? And if you had, say, 10% rate of return, well, then you only have to set aside, what was it, like $57,000. But, you know, you can pick another number. Like if you say your R is 5%, then it'll be something around $75,000 each year that you have to save in order to reach $1 million in 10 years. So that's it. That's where that equation comes from. And it's right here. So you can plug in your numbers and try to find what S is, and that'll give you kind of how much you have to save each year to reach that goal. Thank you.
So thank you for watching. If you have any questions or suggestions, let us know in the comments below, and follow us on social media or our blog at gabbyandjaysjourney.com. Please like this video and subscribe to our channel. Hit the bell to be notified whenever we post new content.
Until then, please stay safe, do your part, take care of one another, and thank you for joining us.